So, what we're going to look at this morning is what's called a first order ODE. Basically, simply put, it's an equation that has dy dx in it, and y in it. It doesn't have to have y in it. And we're trying to find y. So, an example will be something simple like this. This is a very simple first order ODE. And what I'm looking for is the y. And I think you can all kind of see that the y must have been x squared plus c. This is the answer. So, that's obviously a very simple one. How did I get the answer? I integrated. Yeah? Okay, well what about something not as obvious as that? What about, for example, something like this? Now it's a little bit harder because I can't integrate anymore. Last time I could integrate here, and that was okay. But here, if I try to integrate, I have a problem. And what's my problem?
You don't have x.
Yeah, there's no x here. It's only y. Right, well, there is a way to get around this, and I wonder if anybody has seen it before, or can anybody figure out the way to fix this problem?
Add the 1.
xy.
1y.
1y. Nice try, but not this. Anything else?
xy.
What do you mean xy? Put an x here?
Yeah.
I can't just put an x there. I can't just do that, because then I've changed it.
No, I mean the original equation.
Oh.
xy.
dx over dy.
What do you mean?
Like, swap them.
That's not too bad, actually. If you swapped it, dx dy equals 1 over y,
Yeah.
then you could integrate. So integrate this, dy, integrate this, dy. You swapped the x and the y's role. You have the right idea. That's the right idea. Although we don't quite write it down like that, but that is actually the idea. We call this method separation of variables. So the goal is to get the x's with the x and the y's with the y's. In fact, the way you suggest it does this as well. So what I do is I bring the y to the left, 1 over y, and I bring the dx to the right. So I have the x's on the right and the y's on the left, and now I can integrate. So what does this become? Yeah. And what does this become?
X.
Yeah. So what's y? Ex plus c. Which actually, by the way, equals EC EX. Now if E is a constant and C is a constant, then I can just call this a constant. And it's the answer. Very interesting. Okay, so this is our first real example, and this is the method. Separation of variables. Cold, Jerry? Good attitude. Hash brown? Just hash browns?
Sausage.
Ah, nice. Okay. Not okay yet. So, just to continue with this example, in fact, it's possible to find the A but I need to give you extra information. So the question would also need to tell you something about the x and y. So for example, if I tell you y equals 1 when x will say is 0, then this here gives me enough to find the missing constant, because now I can say 1 equals a 0. So then I get a is 1, so therefore I have my answer, y equals ex. Yeah. Now, when you think about it, that makes sense. What's the derivative of ex?
Yeah.
Ex. So is the derivative equal to itself? Yeah, this equation is right, because this answer makes sense. Yeah. Okay, I'll give you an easy one to try, but then we'll do a hard one. Can I scroll down? Yep. Okay, Sean.
It's not showing.
Oh, it's not Sean. Okay. Wrong student. Try this one. Dy dx equals y squared. Find y. You have answers here? Let's have a look. So I'll get 1 over y squared dy equals dx. So I get y minus 2 dy equals dx. Now I integrate. And I get y minus 1 over minus 1 equals x plus c. So now I get minus 1 over y equals x plus c. So that means y equals minus 1 over x plus c. And oh, by the way, I didn't tell you this, but before I get to c, this answer is called the general solution, the general answer. Now let's try and get the actual particular answer. Let me say I tell you, I don't know, y equals 1 when x equals 0. It's kind of the same as the last one. So if I use that, I'll get 1 equals minus 1 over c. So c equals minus 1. So now I have my answer here. Y equals minus 1 over x minus 1. Multiplying the top and bottom by minus 1. And that's the answer there. Okay.
Why is it called general?
General is the opposite of like particular answer, certain answer. It's called general because we don't know what the C is, so you know, could be anything. So when we use general here, we mean like many answers. Does it make sense? Yeah. Yeah.
Why is interpret ds become x plus c?
There's a 1 there.
There's a 1 here. Yeah. It's like 1 here. Now these results are kind of interesting. Here's an interesting side note. Okay, if this is true, that means the derivative of 1 over 1 minus x equals 1 over 1 minus x squared. Now you can check this. What rule gives us the derivative here? Quotient rule, right? So if you use the quotient rule here, you will see that it does simplify down to this. But let's have a look at something else that's interesting. The derivative of, and we know another formula for 1 over 1 minus x. It's 1 plus x squared plus x cubed, etc. That's equal to 1 over 1 minus x squared. The derivative here is 1, that's a 0, 1 plus 2x plus 3x squared plus, and you can kind of see what's happening, 4x cubed, that's equal to 1 over 1 minus x squared. So it's like we made a new formula. Do you know what I mean? I mean, if I said, what does this equal? I don't think you could come to this formula. Or if I said, what does this equal? I don't think you can make it this formula. But actually, using the result of my question, I can make this formula. People who study financial maths, this is a formula I know from financial maths. I can't remember what it's a formula for, but I remember it's a formula. It's only an interesting side note. The reason I think it's interesting is because it's a mixture of an AP and a GP. So if you look here, 1, 2, 3, 4, that's AP. But then if you look at the x's, it's x squared, x cubed, x0, x1, x2, x cubed, that's a GP. So it's almost like you've put the two together. These numbers are increasing by +1, and the x's are increasing by multiplying by x. Like, for example, try x equals a half. You get 1 times 1 plus 2 times a half plus 3 times a quarter plus 4 times an 8, etc., etc. That should equal 1 over 1 minus 2. 1 minus a half is a half, 1 over a half is 2. That should equal 4 when you add them all up. But you have no way of doing it using AP and GP, because it's not AP, because only this part's AP. It's not GP, because only this part is GP. But yeah, we can still get the answer. I just think that's an interesting result from this question. Okay, like I said, let's have a look at a harder one now. Let's see, nice juicy one for breakfast. Okay, I'll give you a medium one, and then well done. Yeah, nice well done steak. Okay, so number 8 is medium difficulty, and number 9 is quite difficult. Now number 9, although it's quite difficult, it has come up on a past exam. It came up one year when somebody wrote a very difficult paper.
Oh, it was you, right?
It was me. It was me all along. So I know number 9 was a past exam question because I put it into my exam when I wrote it. But first try number 8. Okay, I see one person with the answer. Can I see your answer?
1/2x times.
Ooh,
Why is
Not this.
constant?
not this.
No log.
Why is it constant?
No log. Yeah, let's have a look. So what was the equation? dx squared
Yeah.
dy dx plus,
Number 8.
yeah, d,
Oh.
dy dx, right, equals 1. Okay, I think a few of you realise what you should do first is take out the dy dx. Good. And then simply cross multiply. And integrate. And we have y equals tan inverse x plus c.
Oh, that's simple.
Yep.
Oh, we don't have to do the
Oh.
dy dx.
Huh?
When we integrate dy, we don't have to do the dy dx. So now I
No.
forgot the where do we go?
No. What do I tell you to find the c?
Oh, y equals 0.
Y equals 0 and x equals...
No, I mean, put 0 in the aspect.
Yeah, what does y equal?
0 for both.
0 plus
0, 0. Okay. So that means c equals 0. So y equals tan inverse x. What did you do wrong? How did you get log?
No, I use u equal 1 plus x squared. And then
You might have to talk to Connell about your predicting, right?
Oh.
Oh, I'm joking. Okay, did you write that down? Yeah. Now time for an interesting, juicy one. Number 9. Number 9's a great one. You'll like it. Try number 9.
use product.
What is x minus x? What is 1 over x minus x squared?
1 over x minus...
Oh, it has nothing. That's all.
No, it has nothing.
Oh, okay.
Well, no special rule for this. Of course, you can still integrate, otherwise I wouldn't have given it to you. Juicy? Very juicy. Got an answer? Answer?
No, I just want to confirm.
Yeah?
When we integrate 1 over y, do we get log y?
Sure.
Okay. I was confused.
Sure. So this one is x equals to 0, right?
Yeah.
And this one is y.
Yeah. The half, yeah.
How many pure okay?
Sounds like Lee's getting it.
No.
Are you sure?
I can't combine them.
What do you mean you can't combine them? What
I
kind of...
have two, I have log y plus 1 over y equals x plus c. Which I have to combine y together, right?
Yeah. You have log y plus...
1 over y.
Plus 1 over y.
Oh, I did something wrong.
Oh yeah, I wasn't expecting that. Something went... Sounds like you got it half right. Okay, let's have a look. What was the equation? It was dy dx
Y 1 minus 1.
y
1
y minus 1?
1 minus 1.
Okay. Right. So this is 1 over y, 1 minus y, dy equals dx. Yeah. But we don't have any way to integrate this. So what we do, separate it into partial fractions. Now if you go through the trouble of finding the a and the b here, I made it easy for you. I made the a and the b both work out to be 1 and 1. So this will be 1 over y plus 1 over 1 minus y dy integrate equals dx integrated. So this is log y minus log 1 minus y equals...
Oh, it's just log 1 minus y?
Yeah, just this.
I was thinking about the...
No. Y, log y over 1 minus y equals x plus c. Then I'll e both sides. which is equal to AEX by example 1. Of course, I'm not looking for this, I'm looking for Y. So I'll just say this is Y equals AEX minus YAEX if I cross multiply. So taking this over to the left, I get Y plus YAEX equals AEX. Take out the Y, 1 plus AEX equals AEX. Divide, Y equals AEX over 1 plus AEX. Divide everything by AEX, and I get 1 over AEX plus 1. I'll just write 1 over A as B. So I'll get Y equals 1 over 1 plus B E minus X. And that's the answer. Well, actually, I can know what the B is. What did I tell you? 0, 0 or something?
0, 1 over 2.
Yeah.
When X equals 0, Y equals 1 over 2. So that means B will equal 1. And that's the answer. Yep.
Do you mind to know?
Wait, Monica has a question first. Hang on, let me just put some numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, which line am I looking at?
4 and 5.
4 to 5. Yeah. This part here, is it?
No, down there how to begin minus.
Why is the minus here? Oh yeah, because of the integration of this. Because this is actually like integrating 1 over minus 1x plus 1. Because there's a minus in front of the variable. The rule for integrating 1 over ax plus b is it integrates to 1 over a. So if you want to be technical about it, that was like plus 1 over minus 1 in front there. I thought it was juicy. Now Lee, you sound like you got it halfway there.
No, not even.
No, not even.
Yeah.
Okay, right.
Usually it's 1 over 1 over 1. Number 11. Add that, yeah.
1 over, and this is 1 over AEX plus 1. In other words, here, what I did was I divided everything by AEX. So that's how that became 1 over AEX. And that's a 1, and that's a 1 now. The reason I did this is because I could have left it like this, but there's 2 reasons not to leave it like this. Number 1, the x is in the formula twice, and actually it's enough to have the x only once. And another more important reason is this formula has the a in it twice, whereas this one has the a in it once, which I actually changed to a b. So it actually makes my life easier to consider the form like this rather than like this. Although there's nothing wrong with this, just life is easier this way. Although, if you made it that far, I don't think that's going to cause you a problem. Don't worry, I'm not writing your exam this year.
Could be worse.
It's hard to be worse than this, though. Let me have a look. No, that is worse. Yeah.
Is that 1 over 1 minus y is 1
Hang on, this, where, this one?
Yeah, if that is 1 over 1 minus y squared, it's going to be like...
The square on the y?
Yeah, it's going to be like cos
It's going to be one of the cos inverse or sine inverse. But these are in the formula book.
I mean, I was thinking about that, like, cos is that 1 over 1 minus y equals to something else. I was thinking about that, but it was just ln 1 minus y.
Don't know what you're saying, but okay. I know it's confusing.
I'm confusing.
You are very confusing. Continue? Continue?
Which?
Okay. Which line number are you on?
10.
Oh, good. Yep. Okay. Now suppose I had an equation like this. This is extremely difficult to solve. And originally, my coursework plan was to give you an equation like this to solve. Except, just like in semester 1, I break the problem down into 3 tasks. Each task is solvable. So do you remember in coursework 1, you had the goal of solving the cubic equation, but the task was broken down into substitutions that eventually led to the answer. My plan was to do something similar to this one, where I give you an equation like this and you have to solve it by breaking it down into simpler tasks. But I don't think they'll let me do this because it has too much physics in it. Because this equation here, believe it or not, actually represents the motion, or could represent the motion of a harmonic oscillator that's damped. So if this is y and this is x, you could get a solution like this. And you can get other solutions too, but this is one of the possible solutions. In fact, there's many solutions you can get. I don't think I can do this with you as a coursework, but it's still on the exam, but not to solve. Instead, what you would need to know for the exam is how to check an answer is right. So what would happen in the exam was, they'll say, show that y equals ex solves this equation. So for these difficult problems, you're not expected to solve them, you're just expected to check a solution. Do you understand? Yeah. By the way, what do you think these ones are called? Well, if the last ones were called first order, then these ones are called second order. Okay, so let's check. How can I check? Well, let's start with this part. What's the second derivative of ex? Ex. And what's the first derivative of ex? Ex. And what's this? Well, this is minus 2 ex. So that's 2 ex minus 2 ex, which is 0. Which does work. But then you realize, oh, okay, actually, you could have many solutions here, because if I stick a number 3 here, then this one will become what? 3. This one here? 3. And this one here? 6. And this will become 6. And this will become 6. And will be 0. So actually, because of the equals 0 here, this could have been an answer as well. Yeah, and it's actually there's actually one other answer as well that works. Let me think. What is it? Is there one other answer that works? I think there is. But I can't. I need a calculator. Thank you. Okay. Right. I want you to try this one for me now. Same equation. So let me just rewrite it again. So the equation is d2y dx squared plus dy dx minus 2y equals 0. So part 1 I did, check y equals aex is a solution. Now part 2 I want you to do is to check y equals b, e minus 2x is a solution. Okay. Okay, so this part is done. I want you to try this one now. Yeah? Leave him be, he's thinking. She's distracting him.
I know it's still like ordinary.
Differential equation, yeah. Okay, did you get this? So if y equals that, what does y derivative equal? That'll be minus 2be minus 2x, and y second derivative? 4be minus 2x. Putting those three into here, I get 4be minus 2x minus 2be minus 2x minus 2be minus 2x equals 0. Or rather, does it equal 0? Well, cancel. 4 minus 2 does equal 0. Okay, in part 3, check now y equals aex plus be minus 2x. Okay? It's actually a quick way to do this one. Because what you can do is you can say, well, I just need to check the second derivative of this plus the first derivative of it minus twice it. But a derivative of a plus b is derivative of a plus derivative of b. You can separate them. Okay, so I can separate this as twice the derivative of a ex over dx squared. And I can just look at this part. Derivative of aex and then minus twice aex. And then now I can look at the second derivative of the b part. Plus derivative of the b part minus twice the b part. And you realise these three together has to be 0, because in part 1 we said aex makes the three of them add up to 0. We said that in part 1. So we know that this is 0, and likewise we know that this will simplify to 0. So together it's 0. In other words, what I'm trying to tell you is that if you know, where's it gone? Here. If you know this works, and you know this works, then you know adding them together will also work. And you might be wondering, well, how many more could there be to add? And the answer is no more. There's at most 2, and the reason there's at most 2 is because it's second order. There's 2 solutions. Just like in the previous examples, we only ever had to deal with one solution. We never had to add in a second solution. But what is very interesting, can I go back up just for a sec? I want you all to solve this equation for me, please. Give me the 2 values of x.
1, 2.
Not 1, 2.
Minus 1, 2.
X equals 1 or x equals minus 2.
No, minus 1.
Minus 1 and 2.
Huh? What are you talking about, dudes? Oh.
1 and 2.
X plus 2, x minus 1. Right? What do you mean no?
It's correct.
Dudes, what's going on?
2x minus 1x.
This is right.
Yeah, that's correct.
So x equals 1, x equals minus 2, like what I said a minute ago. Yeah, I don't know what's wrong with you. Anna, don't give me this finger swagging nonsense, please. KJ, what's the first answer there? Read it out.
1.
And the second answer?
How did I serve any kind of that?
Anyways, that wasn't the point. The point was, what are the 2 answers? 1 and minus 2. Now look here. What's this number here? 1. And what's this number here? So in other words, there's some kind of link between that and this. But what is that link? You'll discover next year. To be continued.
Oh,
Why
d
not?
squared over the x squared is x squared, and then the
Well, no, it's not quite is x squared, because it's not x squared, it's the second derivative. But there's something about it that's like x squared. It's like x squared, but it's not x squared. Because if it was x squared, it'd be x squared. But I'm just saying, there's something about it that's like x squared. Very interesting. You will discover next year. What are you studying next year? Maybe you'll discover next year.
Why next year, not this year?
It's not on the course. It's a bit too advanced. Anyways, I wanted to do it as part of your coursework, and you'll discover it. But if they don't let me do the coursework, then you'll have to wait till next year.
I think we're done.
I think it's only on the further maths in the A levels, I think. What are you studying next year?
I mean, we're going to university this year, not next year.
Guys, since you had so much trouble doing this part, you're just not ready for it.
I mean, we're just like 2 plus will have to be 1, and 2 times 1 has to be minus 2.
Was a bit embarrassing. Alright, did you write this down? You're thinking deeply about this, I can see.
You can let a equal d squared.
Look, if you really want to think deeply about it and do something about it, my hint to you is to use this substitution, y equals aekx. Put that in and see what happens. That's my hint to you, okay? Right. There you go. Yeah, we'll take a break now. Did you write this down? I can close it? Yep.